Hello, folks. Full disclosure, I work for a financial regulator, but I promise I'm not here to collect more data or ding you for compliance issues. I'm here to talk about how we're replatforming our technology and moving to Hadoop in the cloud that helps us to do better regulation. About FINRA, FINRA stands for Financial Industry Regulatory Authority. We're a very mission-driven organization, and our mission is investor protection and market integrity. We process up to 40 billion market events daily to help us monitor US financial markets. We oversee close to 4,100 broker-dealers and roughly 620,000 individual brokers who trade securities in the United States. So our big data includes roughly 2 petabytes of online storage and 6 petabytes stored offline. So we have to go through this big data and process at a massive scale, look for market wrongdoings. So FINRA monitors 99% of all equities traded in the United States, and data is central to our mission. The first thing we do when we get the data is we try to reconstruct the market activity. When you go to your favorite broker site, you want to buy, say, some shares of IBM, you get a confirmation that your order has been filled. There are lots of things happen behind the scenes in terms of order being sent to an exchange or order being sent to a different broker or order being internally filled via dark pool or things like that. So to form a holistic view of all the events that take place on the stock market, we get data feeds from different sources. So we get data feeds from exchanges. These are your NASDAQ, New York Stock Exchange, BATS, and other market centers. We get data from broker-dealers, investment banks, and we get data from trade reporting facilities. These are facilities where all those exchanges that are not traded, all the trades that are not traded on the exchange, they're being reported to trade reporting facilities, so we get data from them as well. And data is represented, in terms of securities. We look at equities, options, fixed income. At the end of this process, again, this is a pretty complicated graph of billions of nodes and edges interconnected that show a life cycle of a trade that flew from broker to exchanges and back to a customer who purchased those securities. So once we build that graph, we analyze that data for market manipulation, insider trading, fraud, or other compliance issues. Essentially, we're looking at a sea of data, petabyte scale data, and we're looking for a needle in a haystack. We're looking for a behavior that is fraudulent, a behavior that does not meet customers' objectives. The key point here is that this analytics doesn't just run once when we get the data. It continuously runs when data source changes, and in case there are events that happen in the marketplace and we need to rerun them, we have to continuously run these algorithms on a data set. There has been a theme of data kind of segmentation and things like that. Our objective is to really look at data that spans multiple years. So some of the challenges with the big data is the market spike A few times a year, you see big spikes in markets which actually double our data size. So in order for us to be efficient in terms of processing that size of data, we have to over-provision almost twice, which is not very realistic for our loads. New exchange platforms are coming online, and these exchanges are providing APIs to attract new customers. They're building new APIs for be that high-frequency trader or be other broker-dealers to take advantage of that, and that generates more data for us to look at. The regulatory landscape is evolving. Mike Olson talked about it. And FINRA, among other regulators, are not shy to collect more data. As new security products are being created, we have to tweak our analytics constantly to look for those patterns, to look that behavior in the new products, as well as behavior that spans across multiple products. Some folks go into options, they move to fixed income, they move to equities. We got to look at that holistically to see what is happening in the market. And as market manipulators innovate, we have to stay close and understand what those behaviors are in order to protect the investor. So we're in the middle of a 2.5-year program where we're re-platforming all our technology, big data technology, and we're moving away from our data centers, going to the cloud, and moving from a traditional appliance-based technology into Hadoop. So for that, we partner with Amazon Web Services, and we partner with Cloudera to help us shape that technology for future. So before just giving high-level architecture, what we do, and share some of the lessons learned from you, and we have a bunch of those later on the slide, I want to give you a sense of how Hadoop was introduced at FINRA. In 2013, we brought Hadoop as a Tier 3 storage. Traditionally, you heard presenters talk about tiering the data, and FINRA was not an exception. So we had a Tier 1 storage for most frequently used data. Let's say 6 months of your data, you had a Tier 2 storage, and Tier 3 being the least frequently used data store from months. Let's say if you have a requirement to store 3 years of data, that would be 20 months, 24 to 36. So we brought Hadoop cluster into the organization, and we moved the Tier 3 storage into Hadoop. That gave us experience with the Hadoop, understanding how to run it on-premise, operationalize it, making sure we're comfortable with security and things like that. Once we purchased the big cluster and we leveraged storage very effectively, our CPU and memory was kind of idle because, again, it's a least frequently used data. Occasionally, you start pulling the data and analyzing on a historical data. So we tapped into that capacity, we tapped into the memory and CPU and started using that as a validation engine. So as data arrived into the organization, we would validate the data and send it back to the providers of the data. So as I mentioned earlier, this year we're making a significant expansion into Hadoop. We have the big data ETL ported into Hadoop. We have graph processing algorithms where we're reconstructing the activities that happen in the market. We're using HBase for that to look up at the parent-child relationship of data, as well as batch analytics. The insider tradings, all types of wash sales, front runs, all those analytics that we continuously run, we ported that to Hadoop. So looking forward, we're focusing on advanced analytics, and Dr. Bob talked about machine learning and things like that. So that's on our radar for next year, and really working with our partners, Cloudera and others, to make some big advancements in that space. And when you operate at a petabyte scale level, it's all about speed. We want to go into more interactive access of data, and that's something that we will be working together with our partners to make sure that we can achieve those. So other speakers today talked about data governance, data management. And organizations start processing data, say in a relational database, and as capacity overgrows that and analytics become more complicated, they end up buying an appliance. You start working with the appliance for some time, data grows, analytical demand grows with that, you buy another one. So you end up fragmenting your data between multiple stores, multiple appliances. And data management becomes an afterthought. You don't think about how you manage the data, and there are actually 3 problems with that. And one is to understand what data the organization has, as well as where it's being used. It's becoming very labor-intensive operation. I have to put all my BAs and some devs to figure this out. Where is the particular data set in trillion records it's being used? The second problem that it introduces is obviously the sync issue. Now you have multiple stores, multiple appliances that are crunching your data, and you have to make sure that you do the movement of the data properly and make sure they are staying in sync. The third problem that introduced for us is if we want to run analytics across multiple stores, that becomes a mini project by itself. You pull data from one source, you bring data from another, you bring data from third, and you start running your analytics. So you need that extra capacity to put that data in and to run your analytics on top of it. So one of the things we decided to do as part of this replatform exercise is to put data management in front. Start building those capabilities so that we tackle those issues up front. So data management, the box in red, is basically solving 3 things. One, it captures, as the data enters the organization, it registers it. Second, it knows where it came from and where it's being used. Talk about usage and lineage of the life cycle of the data. And third, when you want to run analytics on top of the data, it knows those analytics are targeted for a specific environment, so it orchestrates provisioning of those environments automatically, asks those clusters to use that data, so all this manual labor goes away. So we have the machine that kind of orchestrates our business of data. So on the left-hand side, FINRA Data Center, as I mentioned, we are traditionally a Netezza, Greenplum, NAS, SAN, Oracle, I mean, you name it. Historically, as organically you start growing through mergers and acquisitions, you start having different technologies within the organization. And it's becoming challenging to kind of deal with that depth of technology, to deal with this heterogeneous kind of stores. So data, we're moving to the cloud, as I mentioned. We're moving to AWS, and the data is being stored in S3. Everything is encrypted. We talked about security in the past, that security is a major concern. We've gone through and validated some of the security concerns with our partners, and we feel safe that public cloud is ready for prime data, for storing sensitive data. So the Hadoop ecosystem is very important for us. As the data arrives, data manager decides the ETL cluster, does the transformation of the data, the graph processing. Again, we use HBase for that. That's another cluster. The batch queries, these are our surveillance queries that also leverage Hadoop in the cloud, run on top of data stored on S3, as well as interactive targeted queries. We were able to reach interactive speeds with some of the targeted queries. For example, some of your applications consistently execute the same query with different parameters. For those, we looked at those holistically and were able to partition the data in a way, and again, not fragment, but partition the data, register with the data manager so that those queries perform an interactive speed. So what are the benefits that we're seeing as part of moving into this replatform exercise? We talked about end-user access to this data for those targeted queries. We're seeing interactive speeds. The order lifecycle of the data, when you buy a stock, it builds up this graph at its interactive speeds. Before, that data was calculated dynamically, sitting in Greenplum and Netezza when an analyst wanted to view a graph. Now we're taking that away from doing that dynamically, and we're actually pre-building the graph for it. And results return in seconds. One of the big things that we're seeing is we're unlocking the data. As we're able to process more, we're lowering the cost of curiosity. Our analysts now are able to ask more questions. Our analysts are not afraid to come to technology to say, can you run that suite of kind of algorithms on this data? Because a source has changed and we want to do different what-if scenarios. And the answer is yes. Now we're able to do those things with a fixed-size data center, with a fixed-size capacity. Those things were impractical or impossible for us to do. So we also, the big kind of holistic look at the data, how we manage organizational data, how is it becoming an enterprise asset. We want to make sure this is a once-in-a-decade opportunity for us to replatform and put that in front of all the decisions that we're making. Heavily investment in the data management so that we automate the life cycle of the data, the lineage of the data, as well as the cataloging. What information is incoming into the organization? And the business case was built as part of doing all this. We would see savings by retiring the appliances and moving into the cloud. We're already seeing savings. We're halfway through our business plan, and we have another 12 months to go, but we're already realizing savings. I wanted to share some of the lessons learned with you, because I'm sure many of you are in different stages of going and adopting Hadoop. And one of the things that we had to do, we had to innovate. We couldn't just lift and shift our workloads, our code into the cloud, into Hadoop. We had to look at how we partition the data, how do we store the data, and also look at the whole SQL ecosystem, because frankly, there are many IT organizations that are using SQL. I mean, their analysts are using SQL, the developers are using SQL. Some of it can be repartitioned. Some of it can be processed using different technology. It doesn't have to be SQL, but some of it absolutely must stay SQL because that's the language the analysts talk. We're seeing some changes in our operation. Because we're outsourcing hardware, we're outsourcing capacity, we're spending less time worrying about patches, worrying about next security vulnerability, worrying about how we're going to upgrade our systems, and transforming that operation team into more DevOps. DevOps are writing code, they're writing scripts to go into Hadoop, to go into the cloud, and they're kind of playing a developer function. It's all about people. I mean, this is a pretty big, task, and it's difficult to execute without the right people. And, AWS is hiring, Cloudera is hiring, so you're competing with big firms. But the good thing is that you partner with them, and they bring professional services who have seen many big data problems and give you a jump start. So while you're looking for people from outside, you partner with them to their professional services, and Cloudera has been a great partner for us in that space. I want to pause and talk more about culture and talent, because as you go through this transformation, you start seeing changes in the culture. The developers now working with more modern tools, they're working with modern technologies, and that excitement, that engagement level automatically goes up. So those who are doing HR engagements are not very happy with the engagement of their people. This helps us to boost that morale and kind of work on the cool things. Hadoop is an open source. I guess many people can just go download and run it themselves. We strongly recommend partnering with a provider who has, contributors, who knows how to run Hadoop, and more importantly, we tapped into the Cloudera when we were doing H-based backups on S3. You can imagine you have an H-based database. It needs to be operational. We need to make sure that we back up our data on S3, and the original snapshots of that H-base were pretty weak to S3, so they helped us speed up that the process of writing those snapshots to S3. So definitely partner with the Hadoop provider there. In terms of elephant in the cloud, Hadoop is a known quantity on the hard iron, or running on the data center. This space is evolving. We're pushing the boundaries of Hadoop and cloud, making sure that they play nicely together. Again, because you're operating on a level that is above your hardware, and you have to honor some of the physics and laws of the cloud and virtualization. So making sure Hadoop performs well in the cloud is something that we're very passionate about. And any changes that that we're asking the vendors are doing, they want to make sure they're checked back into the open source. Our strategy is cloud, Hadoop, and open source, and therefore we really have good partners that help us with those strategy. So what's next? We're looking at Spark for two reasons. One is we want to get to interactive speeds at a petabyte scale. And right now, it's challenging. We can partition the data in a way that gives us some of our targeted queries run at interactive scale, but if you want to go run your free SQL on a big data at petabyte scale, there's more work to do there. The machine learning, data scientist is, I guess, next big area where we're focusing on. We're looking at Spark, MLlib, again, partnering with Cloudera to help us bring that talent and guide us through lots of unknowns, because it's a new space. It's a fragmented space. We can run Python and IPython R on a single box on EC2, but if we want to scale that on a cluster that runs on a petabyte scale data, there's still work to do there. That space is really maturing. And we talked about interactive big queries. Going faster at the petabyte scale, as well as making sure that you can give those to our analysts and users who are not afraid to write those queries, and so to make sure that those queries come back in a reasonable time. That's the end of my presentation, and thank you for your time.